Good afternoon, everyone, and thank you for joining us. My name is John Miller. I'm the Managing Director for our operations communities here at the Manufacturers Alliance. Thank you for joining us today for our Deploying Private 5G for Mission Critical Comms, a case study webinar. For those who are new to the Manufacturers Alliance, we are a nonprofit membership organization supporting the manufacturing community since 1933. We help manufacturing leaders make smarter business decisions through professional development events like this one, and our membership, which connects executives with peers in similar functions from the manufacturing industry. Just a few housekeeping issues today. Attendees are on mute, but you do have the opportunity to type in questions throughout today's presentation. Feel free to write your questions in the Q&A tab at the bottom of your Zoom screen. We'll be reserving some time at the end to answer those questions. We will be recording this webinar and provide a link to the recording and the slides tomorrow. I'd like to give a big thanks to Communications Technology Services, CTS, for sponsoring and leading this webinar. CTS provides custom carrier-grade in-building and campus connectivity solutions for enterprises and mobile network operators solving and managing the most complex networking challenges. Today, we are joined by Rob Serbone, Vice President of Product Management and Marketing with CTS, and Dr. Boo, Executive Vice President of Engineering with CTS. Rob and Dr. Boo, I will turn it over to you to get us started.
All right, Dr. Boo, you want to go ahead?
Hi, everyone. Thank you for joining. Today, we're talking about mission critical communication during a manufacturing facility. There are trends driving the digital transformation manufacturing, especially after the during the COVID pandemic. There's a lot of the disruption on the supply chains, a lot of staff shortages, drive a lot of the manufacturing companies to look for digital transformation, automation, and to utilize different technology to improve efficiency, improve their operational technologies. So we identified 6 different trends during this pandemic transition period. And one of the main things I mentioned earlier is the staff shortage. During COVID, during the pandemic, we have a lot of shortages causing a lot of the manufacturing companies to look at how we can utilize what we have and try to automate the system they have to improve what the production can do, and how we can improve the efficiency, productivity of the manufacturing plant by using digital transformation or IoT 4.0, Industrial IoT 4.0. The other one is the disruption on supply chain. Everyone probably experienced that, and we all experienced the disruption of supply chain that we cannot find the face mask. There's a lot of the normal supplies of things. So manufacturing companies are looking at how we can maintain the supply chain during this kind of disruption or shortage at times. And then there are a few other trends that we've seen, mostly focusing on operational efficiency between OT, operational technology, and IT, information technologies, and also some other mission critical data and secure data transmission between the internal system and external systems. So for all these trends driving digital transformation to utilize different technology that's not existing before COVID. So we're looking at right now a third different technology in terms of private cellular that can provide connectivity, wireless connectivity within manufacturing plant. Rob, the next slide, please. So during the COVID and before the COVID, and the private cellular technology in the United States has started. And after the COVID, that really accelerated the adoption of private cellular. Compared to the traditional technologies, the private cellular has a few advantages, especially when you compare to some wired technology. This gives you flexibility to deploy your system much quicker and much more cost-effective way. Compared to the standard Wi-Fi technology, I think the private cellular has more range and more flexibility and more secure network in terms of authentication, in terms of data security. And compared to the traditional cellular network, private cellular give you control of your data. So basically, you deploy your private network with your own policy, your own network, your own data within your plane, and you have full control of your network. So that is really the key factors that private cellular will enable your industrial 4.0 adoption and also deployment, especially in the manufacturing facilities where mission critical secure data are the most critical application that or concerns that the manufacturers have right now. So next slide, please. So we have a case study about one particular customer of us that is trying to deploy and build a manufacturing plant in the southeast United States. They have a global manufacturing plant outside the United States. During the COVID and after the COVID, they realized that needs to really build a plan in the United States to bring some of the chip manufacturing capability to the United States. So when the COVID kind of ended, they really accelerated their deployment of the plant in the United States. And one of the main focus is to deploy this private 5G network so that they can enable their daily operations. There are a lot of the IoT devices within this manufacturing plant that needs connectivity almost 100% of the time. Any interruption, any disconnection will cost them thousands and sometimes millions of dollars. So one of the main focus is to keep all the devices connected 100% or almost 100% time. The reliability is the number one concern on this particular manufacturer plant. The other one is this is a very highly secured facility, and you're not allowed to bring your personal phones and personal device into the plant. So everyone needs to be very concerned, very careful when they walk into the plant, go to the security check and all that. So in terms of this, the cameras, security devices, that is one of the main concern of the plant. So they wanted to put all those security devices onto the private cellular network. The other concerns on their deployment operation is the latency of the network. They're going to have robots moving around. One of the focus is to make sure those robots can move smoothly, transition between one location to another location without dropping any packet data. So low latency is one of the main concern. The other one is they are going to reshape the floor design on a regular basis. The concern is that how do you utilize the space efficiently without have to wire or rewire any of the connectivity already in place. So the private cellular gave them the best of flexibility to deploy all those devices without have to rewire a lot of the devices. So among all these concerns, one of the top reason they chose private cellular, especially in the CBRS, is that they can control the spectrum. They can control the data so that there's no outside influence or there's no impact from the surrounding areas or macro network to these facilities. So the major design consideration is to utilize the CBRS. Then also they want to deploy the 5G SA standalone network so that to utilize all the low latency and all the ultra reliable functionality of 5G SA to connect to up to thousands of devices at the same time. So those are the requirements for this particular facility, and then we're going to show you how we deployed in a case study here. So as I mentioned earlier, the main concern is reliability of the network. So in order to meet that reliability, we decided to deploy a fully redundant network that in terms of all the core networks, servers, switches, and also the RAN side of the network that includes all the baseband unit, control unit, digital unit, and our remote unit, everything down to the cabling and antenna. everything is redundant, fully redundant network, and they're all cross-connected to each other so that any single point of failure, there's a failover that will support the activity, support the connected devices. This is very unique in that perspective where we even have two separate backhaul so that we can guarantee the connectivity to the Google SaaS is always maintained. We also have two GPS runs so that all the timing synchronization on the radio side, on the radio network, it's all maintained in any given time. So this is a very robust and very stable network so that any device failure will not affect the operation of the network. From the user perspective, they won't even experience any downtime or interruption if there's any hit on the system. And the main difference in terms of this one versus a lot of other design is that we are utilizing what we call active operation on the Druid core side, as well as on the other radio side of the network, where when you have one network impacted by whatever outage, the other network is actually active, so you don't have to wait for the secondary system or underneath layer to be turned on. Typical deployment is active standby, so there will be a transition time. When the first layer, primary layer, is impacted, the secondary layer will have to take some time to go from standby to active. We deploy this as a active network, which is very unique in that perspective, so that there's no transition time and all the interruption is minimum in terms of the user experience. This is and currently it's a live network, and we're going to grow from hundreds of devices to 1,000 devices in the next few months. So this is I believe is one of the first 5G SA deployment, especially in this fashion, fully redundant and dual layer deployment. All right, I'm going to transition to Rob so he can discuss in details on some of the specific use cases.
All right, thanks, Dr. Vu. So I think Dr. Vu talked a lot about the network itself and how the key requirements were really around the reliability of the network and having that redundancy and very low transition time. I wanted to talk a little bit about some of the use cases that this particular customer is looking at. And a lot of these are not necessarily unique to this specific customer. We're actually seeing a lot of the similar types of use cases across the industry. So the first one is really kind of connectivity between the manufacturing execution system and the equipment itself that's actually on the inside the clean room and inside the fabrication facility. And that's used for a couple of different purposes. It's used for command and control for some of the equipment or the tools as the raw wafers kind of move through and become finished products, finished semiconductors at the end. So it's used for some of managing the tools themselves, but also for monitoring the process as those work in progress transition throughout that facility, as well as kind of looking at the equipment and kind of managing the maintenance and monitoring. So they see kind of some issues start to come up. They need to be able to react in real time to adjust the process so that they don't lose yield and have any kind of downtime or even worse if the production is actually getting they've got errors in the production where they're starting to have poor quality come through. As Dr. Vu mentioned, I mean, they can lose thousands, if not millions of dollars for any small piece of downtime. So it's very critical that this communications exists. And, for the customer, they really need to have that reliability, that low latency communication between that manufacturing execution system and the equipment itself. So what we have is we've got some 5G gateways that are providing that connectivity to this equipment that is not inherently wireless. So, a lot of these gateways exist today. We're able to connect things via Ethernet ports or USB or even serial ports. And so that was one of the use cases. And again, we see this in a lot of different types of manufacturing facilities, not just semiconductors. The secondary use case here was really sensors that are used for environmental monitoring. So there's a byproduct of the wafer production. There's the wafers get etched, and as those wafers get etched, there's chemicals that get created. And part of the process is to really monitor those chemicals to make sure that there is no breakdown in that process that then causes those chemicals to build up. There's a lot of highly skilled, highly educated employees like inside those clean rooms, and so if those folks get, either injured or even worse, it's a very bad thing. And if that gas builds up, again, they'd have to shut down operations during that time frame, and every minute that the operations are down costs them a lot of dollars. So it's critical for them to actually monitor these chemicals, and then the software on the back end can actually shut down the processes if they need to, if the chemicals start to get into a level where it looks like it's trending towards a hazardous condition. So again, it's very, very important that you have a reliable network for that communications and that low latency, so that you've got that real-time feedback on that process, so that you've got that feedback loop, that if things start to build up, they can shut it down immediately so that nobody does get hurt. The third application that they're looking at is really kind of, Dr. Boo touched on this a little bit, safety and security. So you've got folks that are going in and out of these clean rooms. And one of the applications is really just making sure that they have the adequate equipment, personal protective equipment on when they walk into the clean room. They need to be clean. So they can't have any contaminants that they're going in there. So they've got to have kind of these robes and the hats and goggles. And so there's software that is analyzing video as these people are moving through this kind of buffer area to get into the clean room. And looking at that video, the software can make decisions that say, okay, this person's missing this piece of PPE, or this person is good to go. And so for any non-compliance, the company can make very quick actions to make sure that they get that employee and kind of get them into compliance before they move into that clean room, again, to safeguard that manufacturing process and preserve that uptime. So similar to the first couple of applications, very important that the network is performing, at a high level at all times, and that you've got that real-time feedback loop. The next one, and Dr. Boo mentioned this a little bit, has to do with kind of robotics, and we see this in a lot of different industries, but in this particular space, they're using autonomous guided vehicles. They're kind of robotic pallet jacks almost, to pick up containers of raw wafers or substrates and kind of move those into the clean room so that they can start to move through the production. Again, command and control is very important here, so that they're moving those wafers around and they're not bumping into things, and that they're not running into people, and so that they don't have any damage to the materials, but also kind of getting the materials moved around in a bit of a timely fashion. So that reliability, that low latency communications is critical for that process. I mean, we do see this in a lot of different industries, not only in manufacturing, but it's highly important in the logistics industry. And there's, in addition to kind of these pallet jacks, I mean, we've seen things like, automated kind of forklifts where they're either driving via kind of LiDAR or different kinds of different types of sensors that are on the equipment themselves, or they're being remotely operated by a highly skilled worker kind of in a centralized part of the facility. And they can reduce the workforce where they don't have to have one person on each guided forklift. They can manage multiple forklifts at the same time. But again, it's very critical to have this very low latency, reliable communications, because if the network drops out, for even a second, somebody could crash into something could crash into a person. You can have risk of injury, risk of damage to those goods as well, and neither one of those are good things. I mean, the other thing that's critical here is Dr. Boo touched on a little bit earlier on in his discussion, was just the nature of mobility for these private 5G networks. One of the challenges that we've seen kind of over and over, and some of it with high bitrate applications, but some of it with very low bitrate applications in these manufacturing facilities, is the ability to hand off is a critical functionality, and that could be, it's not something that you think of handoffs when you're driving down the highway at 60 miles an hour and you're talking on your cell phone. But a lot of these manufacturing applications, the actual devices or end users are not moving 60 miles an hour. They're moving relatively slow, could be a walking pace. But it's very critical that those devices hand off from radio to radio. And we've seen on the Wi-Fi side, what tends to happen is the device will hang onto a Wi-Fi access point and wait for that connection to break before it migrates over to the highest performing access point. And we've seen applications where during that process, basically the device just gets hung up because it's still connected to a Wi-Fi radio on one side, but the connection is so poor that there's not enough data kind of coming through. So the device itself becomes bricked, which is certainly not something that would be good if you've got kind of a vehicle that you're trying to navigate around inside a facility. And that's kind of a real basic functionality of these mobile networks, that there's kind of awareness of the network and the devices, and it's really kind of the network itself is moving the devices to the highest performing radio. And so that's something that we're seeing that's very critical in a lot of these manufacturing applications that require mobility that could be, a little bit more nomadic mobility than, as I said, a 65 mile an hour vehicle going down a highway. The next use case that we're seeing inside this facility is guided rail cars. So you can kind of see these a little bit. They're hanging off the ceiling here, little rectangular boxes. I mean, they're moving the product inside the clean room between the different tools or different kind of workstations in the manufacturing process. So once the autonomous guided vehicles, the kind of pallet jacks kind of move in and bring the raw wafers in there, moving between the different stations is done via these rail cars. And then these rail cars are also taking the finished products back out into the packaging area where they're packaged for kind of distribution. And probably the autonomous guided vehicles will be picking them up and moving them around in the logistics facility. So these rail cars, they're on a rail. So, the kind of, I guess, the 3D navigation is a little bit of a less important, but it's definitely critical, the scheduling element for moving them around to make sure that the different pieces of materials or kind of in-process materials are getting from one station to the next, and making sure that the schedule is on time so that the process is being routed as efficiently as possible, and that there are no collisions or errors kind of throughout that process. The last one really that we're seeing, and this is a little bit more futuristic in terms of the specific customer, but it's kind of this augmented reality, less virtual reality like you'd have in kind of a video game or something, or trying to simulate a process, and that's certainly exists as well, but more augmented reality where you've got a worker that is a connected worker. They've got a set of smart glasses on, and you can project information up inside those glasses as they're kind of looking around the real environment, right? And so that can be used for quality control purposes, so that they can kind of, as they're scanning, they can feed some of the information that's being taken off of the glasses as a camera back into a system to kind of look at the finished good product to try and detect or isolate any kind of bugs or manufacturing defects, I guess is a more appropriate term, in the finished products, as well as in some cases. I mean, we're seeing this for manufacturing processes themselves, where you've got kind of more of a manual kind of manufacturing process, that kind of the instructions or guidance for that process can be overlaid on the glasses, so the user doesn't have to kind of look away while they're assembling something. They can kind of see it in their field of view and kind of streamline the efficiency of that manufacturing process. And we're also seeing this a lot in terms of logistics applications for, a lot of inventory gets barcoded right now. And so the ability to identify kind of inventory inside of a warehouse, either if it's an ingredient or a raw material that's going into a manufacturing process, making sure that they've got, the right ingredient, the right chemical before they kind of move it into that process, or kind of coming out the other side, if you've got finished SKUs, making sure that those finished SKUs are going to the right places inside the logistics facility, so that when they do get kind of packaged for kind of shipment or distribution to the end customer, that the right products are getting to the right place in the right time. And that all involves having kind of, again, very reliable, low latency communication so that the end users got a very consistent experience there. And so those are kind of the major use cases that our customer had in this specific facility. We do tend to see some other use cases that we've been working with other customers that involve kind of connectivity. Like Dr. Booth said, some of this connectivity is just being able to free wired connections to wireless. So there's a big value proposition there, and just having that operational flexibility of not having the wire there, but having that wireline-like performance, and being able to do that at a lower cost and more predictable performance than what we see on the Wi-Fi side. So I think with that, John, we're going to open it up for questions, right?
Okay, sorry about that.
That's okay.
So yeah, we have a couple questions. Very, very good presentation. The great use cases and sort of seeing it in play in a manufacturing facility really makes it make a lot more sense. So thank you very much for that. A couple things that came up. Can a private network support voice, text, and video services like a public cellular network? And does it include 911 too as a service?
Yeah, I mean, a lot of what we're seeing today, specifically inside the manufacturing vertical, tends to be more what I would call a private network, I guess, where it is truly private, connecting kind of like the mission critical enterprise applications, and not so much providing a coverage extension like bringing the Verizon or an AT&T or a T-Mobile network indoors. But these networks do have the ability to kind of do that, and that's actually one of the kind of the benefits of this type of a network, is that you could put in a network that, using the same set of infrastructure, you could share between both the kind of the private use cases like we went through, as well as cellular coverage enhancement for each of the big carriers. Right now, it's kind of limited to primarily to T-Mobile and AT&T, but we expect that other operator would come on board soon. And in that use case, I mean, you do have all your traditional voice, video, data use cases, texting, and there is the ability to do 911 there as well. It's kind of an emerging use case for these types of CBRS-based networks.
Thank you. Does it also support use cases that require sort of live uplink streaming, video, that kind of thing as well?
Yeah, I mean, Dr. Boo would probably be a good one to talk about that, because one of the considerations that you have to have with video is really understanding, is that if it's a lot of upstream data, it does have a pretty significant impact on the network design. So I'll let Dr. Boo take that one.
Yes, thank you. So one of the benefits of deploy 5G networks that this 5G has a lot more flexibility in terms of balanced uplink and downlink traffic. So compared to LTE, 5G provides you a lot more configuration-wise on the TDD time slots, so that you can almost allow all the time slot to be all uplink, and versus traditionally you have much more heavy downlink versus uplink. So in the uplink heavy traffic applications, you can adjust your 5G configuration so that most of the traffic is heavily on the uplink side. And then you can also do the network slicing so that different applications have a different configuration-wise. So you can allow different data throughput and also different latency by designing different KPIs in the different APNs. So
Yeah, so some data collection may not need to be real time, and that can be at a different a segment than something that's more real time necessary, correct?
absolutely. So a lot of the IoT devices, they are very real time and they are short packets, but are constant, continuous data request. On the radio side, on the video side, sometimes you have a lot of data, but you can break out the data into local storage, local MAC, where you can store the data and then you can review the data by some sort of application or AI tool on a later time. So you could do the local breakout where the data can be stored on site and they don't have to send to a centralized location.
Yeah, that makes sense. So you guys just showed a really good example of a brand new factory build. So what about when you're doing a brownfield or retrofit application for 5G? What's the challenges there?
Let me take on that, and Rob can chime in. So So certainly we have to look at the existing facility and the existing infrastructure. There are multiple ways to add 5G or private CBRS-based network to the existing infrastructure. A lot of traditional DAS cellular network, you can add in a way by adding radio unit in the IDF clauses, or depends on how you laid it out. You could have additional fiber that you can utilize to add additional radios to it. And then in the typical small cell deployment, where all kind of Wi-Fi deployment, you would have to traditionally utilize the IT or Ethernet infrastructure, switch infrastructure, and then you may have to put additional category cable to connect to the 5G specific radios. There are multiple ways to retrofit existing or brownfield systems, but it all depends on the use case, the environment that you're in, the infrastructure you're already in place, and then where you wanted to have the 5G. That's really important to look at the overall design and how you add the 5G to the network. So.
Yeah, we've actually seen a lot of cases where we can reduce the cost of a new build inside an existing environment because we can reuse some of that infrastructure, like Dr. Boo mentioned, which can, just brings the cost down, savings for the customer. So,
yeah, that makes sense. So, a big concern for everybody always is security. So, is the 5G environment as secure as the other applications that they're using, or the other equipment they're using?
Rob,
yeah, I mean, I think, in a lot of cases, what we're seeing is we're going through a lot of effort to extend the existing security policies that are on the enterprise into the wireless domain, rather than have to kind of recreate the wheel. And so, as part of that, our systems have gone through pretty extensive third-party audits to make sure that we've got those things in place. And it really depends on, I think we can, in most cases, make the network as secure as the customer would want it to be, so that it's not, the weak link. I think the situation for this particular deployment, they wanted to have a very high focus on security. So we've got the entire mobile core is actually running on their site. There's no elements that are kind of outside the firewall. Most of the applications that are consuming the data are inside the firewall. So there's not a lot of risk there. I mean, we have a very small connection that's going outside the firewall just for kind of some overall management functionality, but that's secured via pretty strong VPNs. And I think that where people start to think about challenges here, which can be bridged, are a lot of these devices, the IoT devices are, depending upon the type of device, if it's just a sensor, they don't have very sophisticated operating systems, right? They're kind of unmanaged devices. And so there's things that you can do to secure those types of devices as well. If you move to kind of a zero trust environment where, every device is only trusted to the network and the devices can't communicate with each other. So if something does happen and one device gets kind of compromise, that device basically you can have just shut down and moved off the network until you figure out what's going on. In terms of the radio infrastructure and the communication between, the device and the radio network, I mean, that's fairly secure. There's been, a lot of papers that have been written around the security of the wireless networks here from a cellular standpoint versus Wi-Fi. Out of the box, it's much more secure. You've got to have a SIM card in the device. The enterprise would issue that SIM card. The device is a trusted element to the network, but the network is also trusted to the device. So it's very difficult for somebody to just go in and stand up a radio and have a device connect to that. Like you can have in Wi-Fi, where you have people kind of stand up a honeypot Wi-Fi network and put the same SSID. You can capture that traffic. It's something that's extremely difficult to do on the cellular side. So I mean, that's actually one of the inherent benefits of having these types of cellular networks, 5G type networks, over other wireless networks.
Thanks, Rob. So just a reminder for the attendees, if you want to type a question in the Q&A box, then we'll address it to Dr. Boo and Rob for you. So let's see here. So this may be a big investment for some people, and maybe they are looking at it differently. So can you talk a little bit about 5G as a service and what that does for somebody who's looking at, applying this to their environment?
Yeah, I mean, one of the things that we see with, with any new technology, it's just kind of the learning curve for the enterprise to kind of get up to speed. And here, the benefit of this network is really the ability to apply pretty complex policies to the network that would, again, extend kind of what's going on in the existing enterprise LAN environment over to the wireless network, right? So if you've got a video camera, we can apply policies and create a stream that makes sure that the quality of that video always gets through. If you need to have low latency, you can create a separate policy for those types of devices. There's a variety of different things you can do there, but in order to do that, you have to understand kind of the mobile core and how those networks work. And for, a lot of enterprises, I'd say probably, maybe larger enterprises might look at kind of bringing some of that expertise on board. But the challenge is, you can never have one person. You usually have to have one person, a backup person. You've got to have somebody that understands the radios, somebody that understands the core. So you quickly get to kind of a big team. Whereas, if you've got a partner that can do this as a service, you can kind of turn the network operations over to the partner, let them kind of run the network as a service for you. And then you can just kind of focus really more so on your business, right? And I think a lot of particularly the manufacturing side, I mean, we see a lot more emphasis on the operational technology side, right? Getting all these applications to work inside the manufacturing process to make sure that that's all running. We'll keep the network running to make sure that all those applications can work. And what we've seen is it can be a bit more cost effective if you outsource kind of that management operations and that expertise to a third party that can scale that side of the business than it can for an enterprise to kind of move a lot of this management functionality in-house.
So we just have a couple minutes left. So would you like to talk about any other examples of how your customers are using 5G or LTE?
Yeah, I mean, we talked about some very specific use cases, but right now we're seeing a lot of high-level use cases for this kind of these private cellular technologies. I mean, one of them is really just kind of connectivity that requires wireless, right? And we see this a lot on a campus environment. We're seeing it in manufacturing facilities where you've got multiple buildings across a campus, and they're moving kind of work products between the buildings before the work product is actually finished. So that we're seeing it with kind of jet engines or automobiles where they've got communications that they're satisfied with kind of inside the buildings as they're moving things around. But once they get between buildings, kind of tracking those either that work in progress or the assets themselves that are moving things around, gets to be a challenge, and they've tried to do that with Wi-Fi, but the power limitations that the FCC has imposed make it very expensive to kind of put a Wi-Fi network outdoors. And so what we've seen is on the private cellular side, we can kind of cover those campus environments in a much more cost-effective fashion, for sure, with assets that are kind of moving around on those campus environments, right? And so the coverage that you can get with these types of networks on an outdoor basis, you can cover an area with one radio that's a cellular radio that is maybe, would cover 6 to 8 Wi-Fi access points. So from a cost-effective standpoint, that's definitely there. And even for applications that are not mobile applications, right, where you've got kind of outdoor applications where you don't have a wire. We've seen for perimeter detection or kind of security surveillance where they're covering the outdoor areas of more of the property on a manufacturing facility where they've got a product that they're manufacturing that they don't want people to see how it's being manufactured because that's maybe a proprietary process, or the product itself, they don't want their competitors to know what's going on. The ability to put remote surveillance cameras and perimeter detection around the boundaries of the facility, to run a fiber could cost, $10,000-$15,000 to run a piece of fiber out to a location to get a camera on board. But, with a private cellular network, you can get a camera out there for a fraction of the cost of running a fiber and still get that high quality that they need to make sure that they're able to safeguard those assets and that property. So that's another use case that we didn't really touch on.
So a question just came in. Maybe we got to answer this real quickly. How can 5G be leveraged in retail stores to personalize the shopping experience for customers while simultaneously optimizing inventory management and staff efficiency?
I mean, for the staff efficiency side, there's it goes back to connecting the workers so that they've got access to the tools in real time to be able to do, what they want to do. I think in retail, a lot of that's probably around like more point of sale access or access to information. In terms of like inventory management, I mean, certainly asset tracking, you can use this type of a network for, and then for the employee, I'm sorry, the customer kind of coming in there. I mean, you'd have to get the customer on the network. So assuming you could get them on the network and get a SIM out into the device, there's a lot of things that can be done that we've seen in environments that have a lot of guest foot traffic where you can use this type of network and that connectivity for kind of wayfinding, get that guest person or customer to where they want to be inside that retail facility, where the inventory is that they want to get access to, or to help guide their journey throughout the store using location-based services.
Yeah, I think I just want to add it, right. The one of the benefit of 5G that is you can define use cases based on different applications. So you can define a different APM for the public to use and versus the private use. So you can slice the network so that you can utilize different KPIs for the customer experience versus the inventory management, where customer experience may need a lot of the video, high, kind of the high throughput when they like see the real data or what related to the experience that they see versus what they can search online, those kind of things. And then the inventory side is more on the point of sales, is more transactional, more stationary here, that the mobility is more important on the customer side. So we can design it, the different use cases, different applications within the same one network.
So Dr. But you started to answer the question online that came in.
Yes.
Wi-Fi versus 5G benefits that are at each access point, you have more devices connected and a lower latency, or is it the latency similar between the two? They're looking at like 20 milliseconds response, if that's an issue.
Yes, I was typing now while talking, so it's a little bit harder for me.
Yeah.
I think let me just explain that a little bit on the 5G capacity as well as latency side. The capacity, certainly 5G, you can deploy such that you can support more simultaneous users in a given access points versus Wi-Fi. And also, because of the cellular technology, the capacity is managed on the core side, you can really distribute the capacity more evenly as far as compared to Wi-Fi. And then a latency question is a little bit tricky because latency part is related to how you design your infrastructure network. So one of the things that you can improve latency is you have local breakout where you are user plane data and control plane data kind of separated, where users or the useful data can be locally break out to your server's application. That way will reduce your latency in terms of data packets. So there are different ways to improve latency, but in general, I think 5G has lower latency on your typical Wi-Fi deployment. But to meet the 20 milliseconds, certainly it's achievable on the 5G side. It really can depending on how you design your network infrastructure. And then there's another question: how dense the deployment 5G device in comparison to 802.11 apps? How does it contract with client support per 5G node to 802.11 WAP? So I think Rob, you mentioned a little bit of that. In terms of the density, I think the 5G radio, each one of them, especially on the outdoor, I think we were talking about the range is 5 to 8 times more range than the wireless access points. Indoor, we're talking about 3-to-1 ratio, roughly.
Yeah.
So one access point of 5G can cover probably 3 to 5 times the area of the Wi-Fi access points. In terms of the client supported 5G node, that really depends on different OEM that you choose for the 5G deployment on the radio network side. Some of them can support up to 1,000 per radio versus some of the small cell deployment started with 64 to 128 users per radio. So, but that's still much more than what a typical access point can support in the 30 to 50 range.
Yeah, and even on the Wi-Fi side, I mean, I think part of the challenge you see with Wi-Fi is that the more devices that you get connected to each AP, the performance of that radio actually, the performance for all the users starts to come down. Whereas as the cellular networks scale and the number of connections scale up, you can preserve that predictable level of performance. I think that most of the quoted Wi-Fi capacity users per radio, or people don't usually deploy up to that because the performance, the user experience to each individual device gets very poor.
Well, Rob and Dr. Booth, thank you so much today for your insights on this topic. This is important to many manufacturers. Again, I want to thank CTS for sponsoring this series for us. And to everyone on the line, thank you for joining us. As a reminder, you will receive a pop-up to complete an evaluation form when you exit Zoom. We appreciate your feedback that you can give us. And thank you again for your time. And hopefully we'll see you at a future webinar. Thank you, everyone.
Thanks, guys.
Thank you.